Hi, this is Saraswati. Welcome back to my YouTube channel Brahma Saraswati. Today's class I am going to explain multiway branching construct in behavioral modeling. In this video I cover the topics of first one, what is multiway branching construct, second one, case statement, third one, CaseX statement, fourth one, CaseZ statement. Coming to the first topic, what is multiway branching construct? You see the first point in VERILOG, multiway branching is a mechanism that allows for the selection of one outcome among multiple possible outcomes based on the value of particular expression. This point means you observe on the display there is a 4 into 1 multiplexer diagram and it's a truth table. 4 into 1 multiplexer has a 4 inputs I0, I1, I2, I3 and 2 selecting inputs S1 and S0. Only one output out. And you see the truth table. There is a truth table has a 2 inputs, selecting inputs S1 and S0. The output is out. When S1 and S0 are 0, 0, the output is I0. S1, S0 are 0, 1, output is I1. When S1, S0 are 1, 0, output is I2. And finally, S1 and S0 are 1, 1, the output is I3. You observe the truth table. The output has 4 possible conditions I0, I1, I2, I3 based on some certain selecting inputs. You have to select only one output at a time out of these 4 possible conditions based on selecting input expressions. This is called multiway branching constructs. The next point is, this is typically done using the case statements. In multiway branching construct uses the case statements. The next point is, VERILOG provides case, CaseX and CaseZ statements to handle situations where signals might be unknown or high impedance states. This point means, by using case, CaseX and CaseZ statements, it handles the unknown or high impedance states. The last point is, it is providing greater flexibility and robustness in modeling. Second topic, case statement. First point, the case statement is used to implement multiway branching construct based on the value of single expression. This point means the case statements are used for the value of single expression. The second point is, it allows you to specify different actions for different values of a single expression, making it a concise way to handle multiple cases. This point means, earlier we discussed 4 into 1 multiplexer. In that multiplexer there is only one output, but it has 4 possible output conditions based on different actions of selecting inputs. This is making a very simple way to handle multiple cases. This is called case statement. Coming to the syntax of case statement, this case statement syntax right after always blocked. You see the syntax. First, case expression. Here expression means the input expression. In input, how many possible conditions in input? For example, if we are take selection inputs, how many possible input conditions we have? This is called expression. After case expression, we are writing the value 1. This value 1 is a expression value, selecting input value. For example, if you are take 2 selecting inputs, there is 4 possible input conditions 0, 0, 0, 1, 1, 0, 1, 1. If 0, 0 is a value 1, 0, 1 is a value 2 and a default remaining 2 conditions. This is called expression values. After value 1, we write the begin end block. Between begin and end, we write the code to execute if expression is equal to value 1. Next, after value 1, we write the value to begin end block. In begin end block value of value 2, we write the code if expression equal to value 2. After that, last condition is a default condition. If both value 1 and value 2 is not matches, then the default value will be applied. Default begin end, between begin and end the code will be executed. If if you observe code to execute if expression matches none of the above values. After end case, if we are starting with case and end with end case. Let's see the case statement example. You see on the display, any VERILOG program start with a module keyword module, and module name is a case underscore example. After that, open bracket. In this open bracket, we write the input and output ports. The input ports are represented as a bytes and output ports are represented as a registers. First, you see the input wire square bracket 2:0 selection input. Selection is a input terminal and it has 3 input terminal. 2:0 is a total 3 terminals. It is represented as a vector representation. And after that, output ridge square bracket 7:0 data out. Data out is the output terminal. It has total 8 outputs. And after that, close bracket semicolon. After ports declaration, we write the always block. Always at the rate of open bracket star close bracket. In star, we write the any possible events. And after always, we write begin. After begin, we write the case. In case, we write the selection input expressions. You see the statements below. You see the first statement 3 tick B000 is to data out equal to 8 tick HAA semicolon. In first statement 3 tick B000 is a selection 3 selection inputs. It is a binary representation 000 first condition, and when 000 the data output is a 8 tick hexadecimal representation AA output. You see the statement 2 3 tick B001 when selection inputs are 001 the data output will be a 8 tick hexadecimal BB is a output. And after third statement is 3 tick B010 when selection inputs are 010 are inputs, the data output is in this condition 8 tick hexadecimal CC. As per the in fourth statement, the inputs are 011, the data output will be a 8 tick hexadecimal DD. In fifth statement, inputs are 100, the data out will be a 8 tick HEE. And last default condition, other than these input conditions, we write the data output as a 8 tick HFF. And if we begin with a case, then we end with the end case, end module. In this case statement, we are taking selection as a input signals, and by using the selecting inputs, we write different output values, and the default condition is to handle unassigned values to the selection inputs. This is the explanation of case statement example. The third topic is CaseX statement. First point, CaseX statement extends the case statement to handle X or unknown values, allowing for don't care conditions in pattern matching. This point means CaseX statement is a extended version of a case statement, and it is mainly used for to represent don't care conditions. It is represented as a capital letter X or small letter x, but this x value is a unknown value. Unknown value means either it may be a 0 or 1. The next point is it is useful when dealing with designs where signals might be in unknown states, allowing for better handling of such cases. It is mainly used for the unknown conditions. Let's see the syntax of CaseX statement. This CaseX statement is similar as a case statement. In the name of case, we write the CaseX. CaseX expression after remaining syntax is as it is the similar to the case statement, and you have to observe here in value 1, value 2, value 3 or default conditions we write the code, binary code, but in binary code we include the value of x. Okay, don't care conditions we write. If you observe the syntax, we write 3 conditions: value 1, value 2, default condition. In value 1 begin and block, we write the code to execute if expression matches value 1 or include x. In value 1 we write the binary code or any code with include x. In value 2 we write the value 2 or include x. Okay, In default condition, if above the value 1 and value 2 are not executed and not matches, the default condition will be executed and last end with a end case. You observe the CaseX statement example module CaseX underscore example. CaseX underscore example is a module name. After that we write ports declaration. This input as a selection input, 3 selection inputs, output as a data out. It has a total 8 outputs. After that we write always block. After always we write begin. Then we write CaseX selection inputs. If you observe the statement 1, 3 tick B1XX is to data out equal to 8 tick hexadecimal 11. If you observe 3 tick B1XX, here X means it may be a 0 or 1. We cannot declare it particularly it as a 0, particularly it as a 1. It will be possible either 0 or 1 condition. Okay. In value 1, 3 tick B1XX. In XX place we write the 0, 0, 0, 1, 1, 0, 1, 1. These 4 possible conditions we write. You observe the statement 2, 3 tick B 0 x 0. This is the value 2. In this value 2, in the place of x we write the 0 or 1. We write two possible conditions, two possible values, 3 tick B 0, 0, 0, 3 tick B 0, 1, 0. These two conditions, the data output will be a 8 tick H22. Okay, the statement 1, statement 2 conditions, other than statement 1 and statement 2 conditions, the remaining values are the default conditions. Then the output will be a 8 tick H33. The program is end with a end case and end module. The next topic is CaseZ statement. First point, CaseZ statement further extends CaseX to CaseZ include Z or high impedance states, providing flexibility in situations where signals may be in high impedance states. The CaseZ statement is a extended version of a CaseX statement and it is denoted by a capital Z or small z. This Z means it is a high impedance state, and you remember that in CaseX we write the X letter in the value 1 and value 2, but in CaseZ we write in value 1 and value 2 we write Z alphabet. The point 2, it is useful in situations where signals may have high impedance values which are common in tri-state logic and some modeling scenarios. This CaseZ statements mainly used for high impedance values and high impedance states, and it is commonly used in the tri-state logic. Let's see the syntax of CaseZ statement. This is syntax. CaseZ syntax is similar as a CaseX or case syntax. You observe the display, the syntax is CaseZ expression, then we write value 1 begin end block, value 2 begin end block, default begin end block and end with a end case. Between the begin and block we write the code and it definitely matches with the value 1 or it includes with a Z or X. In value 2 begin end block the code exactly matches with the value 2 or it includes with a Z or X. The last one is a default condition. In the default condition begin end block we write the code to execute if expression matches none of the above values. If the expression value 1 and value 2 does not match, the default code will be executed. This is the syntax of CaseZ statement. Let's see the CaseZ statement example. You observe on the always block CaseZ selection inputs. In the statement 1, 3 tick B1ZZ is to data out equal to 8 tick hexadecimal 44. The Z value may be a 0 or 1. You have to write either 0 or 1 in the place of Z. And in value 1, 3 tick B1ZZ, the ZZ has two places has the values of 0, 0, 0, 1, 1, 0, 1, 1. Okay, these 4 possible conditions, the output will be a 8 tick H44. And the next statement 2, 3 tick B0 Z0. In place of Z we write the either 0 or 1. In this condition the data output will be a 8 tick H55. Last one is the default condition. If the above two values are not matched, the default condition will be a executed. The default value data out will be a 8 tick H66. After default condition, we write the end case and end module. This is the example of CaseZ statement. I hope you understand the case, CaseX and CaseZ statements concept very well. If you are watching first time my video, kindly subscribe and support to make lot of videos. Thanks for watching my channel. Thank you.